Today we will discuss solid angle. As we know that the angles are of two types, that is plane angle and second one is solid angle. From the terms it is clear that plane means two dimensional and solid means three dimensional. So, it is an angle formed in two dimensions. As we know, there are two axes or two lines and angle theta is formed in a plane and it is called plane angle. But we will discuss solid angle. So, in the same way as in plane angle, we will define solid angle. So, solid angle is the angle formed at a point O, that is common point, and subtend with the surface, this one is surface, and these lines which connect this surface from the point, it form a cone. So, the angle formed at this point in three dimensions, just like cone. So, we know that what is cone? Cone is three dimensional figure which is diverging from a point O toward in the space, just like this, and the angle formed at the circle in the shape of circle at a point O is called solid angle. So, this angle is called solid angle and it is denoted by d omega. Omega means angle, solid angle, and theta is plane angle. So, we can say that it is an analogy of plane angle. So, plane angle is written by theta and the solid angle is written by omega, and small angle written by d theta and small solid angle is written by d omega. So, we will find the relation or formula for this solid angle. This is small angle. If we extend this cone and diverge in open space, then the solid angle is formed at the center O is 4 pi. So, we know that as maximum value of theta is 2 pi, similarly maximum value of this solid angle is 4 pi. So, we have to prove that the maximum value of solid angle is 4 pi. How we can prove it? So, we can prove by using the mathematical formula for solid angle. So, diagram, we can represent this solid angle like this, that is the angle subtend at common point O, and it is a measure of divergence, this one divergence, and a cone formed with the surface, this one is surface area, it is ds, and this is cone and this angle is called d omega, or mathematically we may write it as ds upon r square. As we know that the plane angle theta can be written as theta is equal to L upon r. L means L upon r, r radius, L arc. So, arc upon radius is called theta. Similarly, ds area upon r square is called solid angle. So, this is the mathematical definition of the solid angle. So, we may write this solid angle or we may define it as it is the ratio of surface area to the square of radius from this figure. So, this is ds and this one is r radius. So, square of radius and ds is area, the ratio of both is called solid angle. So, this is small solid angle. Now, we will find this angle as a whole or total solid angle. So, for total solid angle, we will integrate this formula on both sides. So, taking integration, that is integrating both sides, that is d omega integral is equal to ds integral upon r square, this one. For whole surface, it is closed in total solid angle. Now, if we have to find the value of ds by two ways, either we know that the total 1 by r square ds integral for whole surface, because r is constant and we may take out from the integration, it is r square is common and it is ds integral. Now, this is ds and this one ds, this one. If we expand this ds as a whole, then it will become whole sphere, this sphere. When ds diverging, then it will cover the whole surface area of a sphere. So, we know that the total surface area of a sphere is 4 pi r square. So, we may put this value here, that is 4 pi r square upon r square. So, r square is cancelled out and remaining term is 4 pi, and this one is omega, that is integral of d omega is omega. So, omega is 4 pi. We can also prove it by another formula, that is by using spherical polar coordinate system, that is this is second method, or we know d omega is ds by r square, and in spherical polar system, this ds, you know that ds is r square sin theta d theta d phi. This is area element in spherical polar system, we have already proved it. So, on putting this value here, we will get d omega is equal to r square sin theta d phi over r square, this one, and r square again cancel out, and remaining part is sin theta d theta and d phi. This is small solid angle. Now, to find the total solid angle, again integrating both sides, that is integral of d omega is equal to integral of sin theta d theta d phi. So, on right hand side, integral is double integral, because there are two variables, d theta, the theta is variable as well as phi is also variable. So, we will use the conditions or the values or limits for the theta. So, theta varying from 0 to pi and phi varying from 0 to 2 pi. We have already discussed these limits in the previous lecture, that theta varying from 0 to pi and phi varying from 0 to 2 pi to form a sphere. So, d omega integral is written as omega, and on the right hand side it is theta from 0 to pi and sin theta d theta, theta, and phi is separating out, this is d phi and phi from 0 to 2 pi. So, on solving this integral, we know that sin theta, integral sin theta is minus cos theta, and on putting the limits from 0 to pi, we will get its answer is 2, that is 1 plus 1, and for d phi the answer is phi, and 2 pi minus 0 is 2 pi. So, 2 into this one 2 and this is 2 pi, it is 4 pi. So, this therefore, it is again proved that the total solid angle is 4 pi. So, this is solid angle. If we write this solid angle d omega in vector form, then it is written like this, that is ds by r square. In vector form, we know that r square is scalar quantity, because square of any vector is scalar. So, ds is vector quantity area. So, we may write ds dot r cap. This r cap is unit vector and its value is 1, that is magnitude is 1. So, 1 into ds remain ds. It is only used for direction or for compensating the vector. So, in vector form, we can write it as ds dot r upon r square. So, this is solid angle. Now, we will solve the numerical on the basis of polar system. So, let the numerical, the plane polar coordinate of a particle, plane polar coordinates of a particle at any time t r, r is equal to 6 into e raised to power 3t, and theta is 4 into t, and these two parameters r and theta, these are given in the numerical, and we have to find the radial and transverse component. We will find radial and transverse component of velocity. Velocity, we have to find this radial component and transverse component of velocity. So, we are using r theta, that is plane polar system. Now, solution, we know that velocity is r dot r cap plus r theta dot theta cap. This is the velocity, we have already proved it. So, this is formula for velocity, and first component is called radial component and second component is called transverse component. Radial means this one, transverse means second one. So, radial V r is equal to r dot and V t transverse or V theta, this is r theta dot. So, this second component is called V theta or V t, t means transversal. So, we have to find these two components. So, how can we find the values of these V r? By taking derivative of r dot. R dot means derivative of this r, and r theta dot is transversal component. So, we will do the derivative, we will take the derivative of this theta with respect to t and multiplying with r. So, we can find these both components, radial as well as transverse components. So, for solving these components, that is V r dot and r theta dot, first of all we have to take the derivative. So, differentiating equation number 1, this r with respect to t on both sides. So, we will get this r dot and derivative of this is d dt of 6 into e raised to power 3t. So, this one we know that 6 and derivative of e power 3t, that is again e power 3t, because derivative of this e power theta is same, and into 3t become 3. So, this one is 18 into e power 3t, this one r dot. So, therefore, V r, that is radial component, is r dot and r dot is 18 into e power 3t. So, this is the first component of velocity. Now, second component V theta or V t. So, we can find V t by taking derivative of equation number 2, because V t or V theta is r theta dot, and what is theta dot? We have to take the derivative of this equation number 2, the derivative. So, differentiating equation number 2 with respect to t on both sides, and we will get theta dot is equal to derivative of 4t, d dt of 4t. So, we know that its derivative is 4 because dt upon dt1 and derivative 4. Now, Vt is r theta dot, r into theta dot. So, what is r? R is this 6 e power 3t into theta dot is 4. So, ultimately answer is 6 for the